Okay, here's our second example problem when it comes to calculating percents. We're going to use the same method as before, but this one's a little bit more complicated. As always, feel free to pause and get this example problem down. Ajax has a total of 56 trails. 14 of those trails are double black runs. What percent of Ajax trails are double black runs? Again, this percentage is going to give us some sort of idea about what Ajax is all about. Are there a bunch of double black runs? Are there a little amount? What is it? And that's how percents can help us quantify these type of real world situations. So as always, when we're doing the proportion method, we're going to start with our key. Part over whole equals percent over 100. And I want you to write this out every time because I want you to show your work, but also it's going to help you memorize it the more you write it. Part over whole equals percent over 100. Okay, now let's figure out what the part, the whole, and the percent actually are. To figure this out, we got to go back to the problem. Ajax has a total of 56 trails. Awesome. There is our whole. So I'm going to write that in my whole place. Keep track of all this stuff. 56. 14 of those trails are double black runs. So 14 is the part for this problem. You can think of part like a piece. Like, what's the piece of double black runs? Well, that's 14. I said part. That doesn't make any sense. I'm going to say 14. Okay. Percent. What percent of Ajax trails are double black runs? So it's trying to ask us that. So we don't know that. So we're going to leave that as X. Part 14, whole 56, percent X. Let's fill this into this problem over here. And actually, I'm going to do it over here just because I'm going to run out of space if I don't. So, part is 14. Whole is 56. Percent is X. All over 100. Yes? Yes. Okay. We've set up our proportion. Let's solve for X. We're always looking for a relationship first. Is there a nice relationship here between 56 and 100? No, because I've memorized my factors of 100 and I know that 56 is not one of them. So I can't multiply the 56 and get something nice over here. So when I have no relationship, I need to solve algebraically. To do that, I need to isolate X. Right now it's being divided by 100, so I'm going to multiply by 100. On the right side, multiply by 100 on the left side. My 100s drop out over here, so I've got X. Over here, this is like multiplying fractions together. Now, I could reduce some of this stuff, but I'm just going to leave it for right now because I'm definitely not going to reduce this 100 because that we have a nice trick for when we multiply 100. So I don't want to take that away. That's going to make my problem harder. So I'm just going to leave it as is. I could reduce the 14 and the 56. Those are kind of weird numbers, so I'd have to think really hard about what those are. And I'm actually going to kind of make it easier for ourselves by not reducing. Let me show you what I mean. So I need to multiply my numerators together and my denominators together. And that's pretty easy in this problem. 100 times 14. Well, I know all I need to do is add the number of zeros to the end of 14 that I have here, 1, 2. So I added 1, 2 zeros there. So 100 times 14 is 1,400 or 1,400. And 1 times 56 is 56. Nice. So all that's left is some division. Remember, at the end of these problems, you're going to get a division problem. This isn't a fraction. It is a fraction, but it's also a division problem. So I need to divide 1,400 by 56. And as always, my numerator goes inside the box, the top number. Set it up. Okay. Does 56 go into 1? No. Does it go into 14? No. Does it go into 140? Yes. It goes in 2 times. Let's see what 2 times 56 is. $112. That makes sense to me. 2 times 56 is 112. Subtract, and I'm going to get 28. Yes, yes. Bring down my 0. Awesome. And now I need to guess how many times 56 goes into 280. I'm going to cover up the 1, cover up the 1's place there. How many times does 5 go into 28? About 5 times, so that's a good place to start. And there it is. We got a match. 56 goes into 280 5 times. Yep. 5 times 56 is 280. I'm done. Nothing to bring down. There's my answer, 25. But what does that represent in this problem? It represents our percent. What percent of Ajax trails are double black runs? 25%. Okay, to recap, we created a proportion based off of our key here, and we solved for x by doing it algebraically. That's why we had to do all these extra steps over here. And our answer is 25%. 25% of Ajax trails are double black runs.